In this video, we will be talking about an array of pin fins.
We will kick off first, of course, with the geometry of the array. Like the previous example, this geometry involves a set of pins placed inside an enclosure. Here we see how a pattern is being used to make the design easier. The design involves a total of 9 pin fins and, of course, an enclosure.
After completing the design, we'll now proceed with its mesh. It's preferable to name the parts or the important parts on which boundary conditions will be set later on in the solver in order to facilitate the process of assigning boundary conditions. Unlike the case of the single pin fin, which had a simple geometry, it is difficult to obtain a high-quality mesh instantly with the array of pins, since we have a rather complex geometry, and therefore several techniques may be used in order to enhance the mesh and enhance its quality. One technique used here is called the mappable face meshing. It's a process by which a straight and unchanging surface, such as the surface of the fin or the surface of any side of the enclosure, is selected, and the mesh on that side is straightened and mapped into perfectly aligned squares, which in turn improves the overall quality of the mesh. In the fluid part of this analysis, we will use identical conditions to the ones applied in the single pin fin. With flow cell laminar. All the bases have a temperature of 1000 degrees Kelvin. Also, all the walls of the fins are said to have a coupled treatment. The velocity is 2.5 meters per second. After solving the problem, we will now obtain the temperature contours, and we will see also a similar color pattern to the one we obtained in the single pin fin. Also, the temperature curve is decreasing in a similar manner to that of the single pin fin. Finally, we arrive at the post-fluent results viewer, where we can view detailed temperature contours, velocity contours of the pin fin design. Here we notice an image similar to that we obtained inside the fluent contour section. now we're drawing streamlines of the velocity. The velocity lines that are entering from the inlet and exiting at the outlet. In this section, the colors are labeled as by the maximum and minimum velocities in the region. We notice when the bars are red, this means that they are at the highest velocity, 4 meters per second, and blue corresponds to almost 2.5 meters per second. Now we're changing the color gradient into the temperature region, where blue means 300 degrees Kelvin and red means almost 350 degrees Kelvin. Notice how near adjacent to the base the balls are changing their temperature drastically from 300 to 350 instantly. Thank you for watching this video, and don't forget to watch the third and final video, which deals with single and multiple rectangular fins.